we are going to do calculus now. People, I love calculus, and you know what? You might think it's a difficult topic, but it's not. If you understand what you must do, I promise you, you can score a lot of marks. The marks for calculus is more or less 40, and that's a lot. So let's see whether we can take you on a road where you can be confident about calculus. Let's start. Question 8. 8.1. Determine the first derivative from first principles. Now, people, please remember, if they say first principles, it is the long method with the formula. If they say find the derivative using rules, you use the rules, the shorter method. Now, let's look at 8.1. 8.1. Fx is x to the power 3. Now, the formula that you're going to use is this formula. That will be on your formula sheet. This is an x that looks so horrible there. Right. I prefer that you don't write the formula immediately. You go to the side of your page. You say fx is x to the power 3. Then you say fx plus h is. And then instead of x, you write x plus h, x plus h, x plus h, because it's a cube. Fine, people. Then we go on, and we multiply that. You multiply the first two brackets, you leave the third bracket. You can't multiply 3 brackets together. It is very confusing. Then you will get x cubed plus 2x squared h plus xh squared plus x squared h after you've multiplied that. And it goes on there, 2xh squared plus h cubed. So that one will give you 1, 2, 3, 4, 5, 6 terms. And that's right, because you are multiplying 2 by 3 terms. Okay. Now, people, now you go back to your formula. And then you fill in whatever you should fill in here. Now, if at the derivative of f, you write it there. You put the equal sign there. I saw books a few weeks ago where the learners in all the sums put the equal sign there. It is wrong. Immediately minus 2. And as you see, it is only 5 marks. So please put the equal sign before the limit h tends to 0. And then you fill in all those values there. X cubed, I don't know why I didn't fill it in there, but I will do that now. Plus xh squared plus x squared h plus 2xh squared plus h cubed minus, you see, I think I couldn't get it out on that line, so I went down to another line with that. But then you must also there say minus fx. And what is fx? X cubed. So it's the whole of that minus x cubed. My space wasn't enough there. But that's not so difficult to do that. You fill in what you got there, and then you fill in fx minus that fx. Don't forget to fill in that one, because we tend to forget that. And that, in the end, gave me x cubed is gone. Then 3x squared h plus 3xh squared plus h cubed. Oh, I simplified it there already. Okay. And then minus x cubed, it cancelled with that one. Have you got that? Okay. Sorry, my space wasn't good there. Now I've got that after I simplified all of that. This is what it comes to. You can go and try it at home again. And if you take this and you minus x cubed there, this is fx plus h, and this is fx. You'll see the x cubes are gone. So don't bother about that one. Just do it there and see, and come back and write your answer here. Okay, people. That is now, every term there has an h. You will not have terms there without an h on top. Otherwise, somewhere you went very, very wrong. Maybe with the sign of this one. Okay, they take out h as a common factor because I want to get rid of this. If h tends to 0, what's going to happen here? This is going to be undefined, and we don't want that. So we take out the h there as a common factor. That is what I have left. Cancel the h's, and that is what I have left there. And when the moment I make h 0, this one becomes 0, and that one, so my answer is 3x squared. Let's go back to the original sum. Use your rules. 3 times 1 is 3. 3 minus 1 is 2. So I am 100% correct. People, you could always check yourself by going back to the original sum and use your rules to find the derivative. That will be, it should be the same as this if you didn't make a mistake somewhere. Okay, thank you, people. Next one, 8.2. 8.2. 8.2 looks like this. They said determine the derivative of. Now let's go up and do it there so it's not so confusing. And they gave us fx there. Now people, now they didn't mention first principles, so now you're going to use your rules. But please, 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 that's another thing I've seen in books a few weeks ago. You must first simplify your equation. If it's already simplified, it's fine. That one is already ready for derivative, to find the derivative. But if you have an equation where you have a square root, get rid of it. If there's brackets, get rid of it. If there's fractions with x's in the denominator, you must get rid of it. That one is fine because there's no x. So this one is ready to find the derivative immediately. So we're going to say the derivative is a constant number does not have a derivative. Did I write this down correctly? Let me quickly see. 2x squared. I didn't write the x squared in there. The derivative of that is 2 times 2, 4, x, 2 minus 1. The derivative of this one, 4 times a half gives me 2. 1 less than 4 is 3. A constant number, no derivative. Very easy for a start. Let's go to the next one, and that is 8.3. They gave us this, and they said prove that the derivative is equal to that. Okay, and x must be larger than 1. Okay, I wrote it down there. That is what they gave. And they said prove that the derivative is equal to, let's quickly write it here so that we have it in front of us. Prove that dy dx is equal to 12x power 5 square root y. Wow, that is what we have to prove there. So let's take it step by step. I told you, if you use the rules, you must get rid of brackets. So let's get rid of the bracket first. And people, this will still be wild. Why? You haven't started using the rules. While you are simplifying the given equation, you keep to y, or whatever they wrote there. You keep to that, because there's no rules used yet. Then we say, right, dy dx. The moment you start with the rules, then you write dy dx is this one. That is how you write that in the right or correct way. Now the derivative there, 12 times 1 is 12. 12 minus 1, 11. 6 times 2 is 12. 6 minus 1, 5. The 1 does not have a derivative. Now from there, I can factorize this. You remember previously we had that 7 to the power 2012 and all of those. So I can take out 12x to the power 5 because this and this doesn't correspond in any way. Can you see that? We must get to that answer. So take out 12 to the x to the power 5, then we've got that. And then what is left? If I divide 12x power 5 in there, I'll have an x to the power 6 there, and there I will have negative 1, taking out a common factor. I hope after this sessions, or all these sessions, you will see how to take out a common factor where you have these funny exponents. Okay, people, that is dy dx. So, if I look at this and I look at that, what is the value of y? The square root of y. X6 minus 1. Can you see that? But let's go on. Let's go on. Y is x to the power 6 minus 1. What squared? Why do I say that? This is the square root of this. Can you see that? And in the sum there, they said you must have the square root of y. So y is actually x to the power 6 minus 1 squared. The moment you get the square root, you will get that. And that means this is the value of y. Let's go down and see whether it's true. Yes, people, look at this. If I get the square root of that, I will get the square root of y. Y is this. So, the square root of y is x6 minus 1. And that is 12x power 5 square root y. And that is my y value. Can you see that? The y has got a value. Y is this. So the square root of y will be the square root of that. That's where it comes from. Have you got that? Quite difficult, ne? Yes, people. That's one of the most difficult derivatives that I've seen in our exam papers. And I decided this one is going to be done by you people. Y was given this. But the square root of y is going to be that. So, this is the square root of y. And there it is. But y is this. Have you got that one? Ha! Lekker. I enjoy this. I enjoy a challenge like this. I hope you too. And I hope you're not too tired by now, because I'm quite tired. Because I've been here for hours and hours and hours. But I love mathematics, and I hope you love mathematics also. Right, people. Now we go to question 6 there. Oh, but there's another one there, but I'm going to do these on other pages. There's another derivative there, and then there's a long method there. I'm going to, oh, cha-cha. There's another one that we must still do. There's another one that we must still do. So I'm going to do those two on a different page for you. And I think I did write everything there that should be written there. There's the one. Yes, I can take this one out. And I can now do those two derivatives also with you. I wrote it there, and I did the derivative over there. Here's another one, and I chose this one because it's got something funny in it also. It's very important that you will be able to remove brackets where there's fractions involved also. So I did this one because of that. So we are first going to get rid of that fraction. It's still px. It's still px. Get rid of the fraction, and if I multiply 1 over x cubed times 1 over x cubed, I'm going to get 1 times 1, x cubed times x cubed. Then I multiply this one by that one. It's going to be 4 over x squared. But I'm going to have two of them because this bracket is being squared. If you square a bracket, people, you have x squared plus 2xy plus y squared. So this is twice xy. And then the last factor is 4x times 4x, which will give you 16x squared. Right. There you are still with px. You just removed the brackets. But people, you're not ready to derive yet. Why not? Because you've got x's in the denominator. So what are we going to do now? It's still px. We're just changing the looks of px. We're going to take that x to the top. it's going to be x to the power negative 6. That x to the top, x to the power negative 2. That one can stay as it is. And there I wrote the rules. People, it's so very, very important. Get rid of fractions with x in the denominator. My children's books was always full of hearts, because I said to them, all those hearts are the things that you must remember when you do these sums. Okay, right, people? So that's still px. Now find the derivative. Now you write the derivative there. You can't write the derivative there or there. You first simplify your equation, and then you write the derivative. Okay, now the derivative. Negative 6x, negative 7, because you subtract 1 there. Negative 16, x, you subtract 1 there. It's 2 times 8, negative times a positive, subtract 1 there. 2 times 16, subtract 1 there, it's x. That's your derivative. But people, if they gave you the original px with fractions like that, you're supposed to rewrite it in the same form. So get rid of your negative exponents. So there you have now. Negative 6, you take the x down. Negative 16, you take the x down. 32x stays as it is. There you have the derivative of that lovely little bracket. I wanted you to see this because people, you tend to write the derivative there and there. But all these steps are only simplifying that one. The moment you start using your rules, then only you write the derivative there. Okay, people, that's the one. Then there's another one. This is the other one that was on that page. One with fractions, but I did it there already. Why did I do it again? I wanted to show you something. So let me just see. No, it's not necessary for that one. So we're going to go to question 6a. 6a is find the derivative using first principles. Okay, long method. First thing you do, you say fx is that, fx plus h will be that. You put x plus h in there, you plus x plus h in there. Then you simplify this. It's quite a lot of calculations. You multiply those two brackets first, and then you multiply each term. If you square that bracket, it's x squared plus 2xh plus h squared times each one of those by 3. Remove that bracket, very easy. There's a positive, so it's not really difficult. Now you write your formula. First derivative is equal to. See where my equal sign is? You remember that. Limit of h tends to 0. Then you write the whole of this thing here minus fx, and there's fx. 3x squared, you see it became a negative, and that one also became a negative because there's a negative in front of that bracket. Okay, so there you have your formula substituted by what the values actually is. And people, if you were right in your calculations, the x squares are gone, the 2x is gone because there's no h there. The only thing left is all the terms with the h's. Again, equal to, you write this limit h tends to 0 all the time until you substitute h by 0. Don't just write it once. Don't think you can put these little things underneath. No, you write it there. Otherwise, minus 2. Now I want to get rid of this h. So I take out h as a common factor. This is what I have left. So now I can say h tends to 0. This one becomes 0. And my answer will be 6x plus 2. Let's go back to the original question there. They gave us this. Let's use our rules to check whether we were right. 2 times 3, 6x plus 2. Let's go down and see whether we were right. Da-da-da-da. There it is. We are quite right. People, I promise there will be a sum like this in your exam paper. From first principle, using the long formula. Okay? So please don't forget to make sure that you can do this very, very well. It's 5 or 6 marks in your pocket that you should get easily. Let's go on. Now, people, I also took a fraction like this because I feel that we must really make sure we can do all types of questions here. The fraction is very confusing when you go on in sum. And that's an easy fraction. You can also get 7 over x cubed. One year they gave 1 over x cubed. It was terrible because it's such a lot of calculations. But I just want to show you what you do when you have a fraction there for fx. Now, fx is 7 over x. They said from first principles. What does that mean? Long method. So we're going to say fx plus h is going to be 7 over x plus h. That's very easy, much easier than the previous ones. Then you're going to go to the formula. You're going to say limit h tends to 0. 7 over x plus h, that's the answer to that one, minus fx, that's the answer to that one. Easy, over h. But then the trouble starts, because now I must simplify this. So I went to that side of my equation, because if you do this calculation in there, you get so confused. So I went to this side just with the top, and I got a common factor there. Then I divided the common factor into this, that one into the common factor. It gave me 7, and I times the 7 by the x. Then I divided that x into the common factor. It gave me x plus h times 7 there. Simplify, remove the brackets, that's what I got there, over x times x plus h. So that's the answer to the top. So I'm going to put it there, in there. There it is. Then I take that h and I say, take that, the whole top, and divide it by h. Don't put that fraction on h. You are going to get something wrong there. I divide that whole answer by h. Now dividing by h means I must multiply that by h. So let's see how it's going on now. You still have the limit there because you haven't substituted h by 0 yet. The h's will cancel like that, and you will have left 7, just a 7 over x times x plus h. Right, now I make h 0. Finally, at the end of the sum. So then the limit is gone. This is x squared. This xh becomes 0 and a negative 7 there. Let's check with our short method. 7 over x, the first derivative will be, no, the first thing you will do, you will make this 7x minus 1. And then the first derivative will be negative 7 x to the power negative 2. That's where I got that from. Okay, people, do you understand that one? I hope so. I really hope so. These derivatives are quite tricky, but they are actually very nice and challenging. Another derivative, the last one, because I wanted to show you all the types that you can expect. Now this one looks like this. And they say find the first derivative. Let's make, I think, okay. They didn't give us a y there, nothing. So I thought maybe I must do this method with you. I must say to you, find dx. If you get this, they actually, without any words, they say to you, find the derivative of that one. Okay? Now let's have a look. Let me just close that 2 there. Okay. We must first simplify. We cannot use rules unless we simplify. Get rid of that, no, the square root here. The pi can stay. Get rid of this square root. And how am I going to do that? I'm going to say, what I have here is 4 pi. I bring the x to the top because I am not allowed to have an x in the denominator. Please, please, please remember that. Okay. To get rid of this root there, it's a 2 on top with a little 3 there. If there was nothing there, you would have said 2 divided by 2. Can you see that? Okay, because then it means square root. That one is cube root. Okay, I've simplified, but while I simplify, and I've got it in this form, this must go with me. I must write the dx there every single time. Okay? Because if I give it to you in this form, they actually say dx means find the derivative of. The moment you find the derivative, the dx will be gone. It's a little bit different from the previous ones. Okay, I'm still simplifying. I've got 4 pi x here, negative 3x, only rewrote that to make it clearer. Right, people, now I can use my rules. The moment I use the rules, the dx will be gone. I don't have to write dy dx because there were no y. I don't have to write derivative of f because they didn't give it to me like that. They gave it to me like that. Well, I made it like that so that I can show you how this one is done. Okay, the derivative. 1 times the coefficient of x, the whole of that. X minus 1, so the x is gone there. 2 over 3 times 3 gives me 2. There I showed you 2. No, I didn't show it there. 2 over 3 times 3. Let me show it to you. It's 3 over 1. So it will give you 2. And then you subtract 1 from there. 2/3 minus 1 will give you negative 1 over 3. That is the derivative, but there's something that you must still do because you are a strong candidate. You must rewrite this into positive exponent form. So you take it down there. It's x to the power 1 over 3. Not finished yet. They gave this sum to you with a root in. So you must put roots back. You can. That one will become x with the 3 outside. X to the power 1 with the 3 outside. And that is the final answer to this equation. The derivative of that is going to be that one. Have you got it? Sorry for that ugly mark there, but it will remind you of me, and then it will remind you to work as hard as possible. Okay? And sorry for the ugly handwriting. I'm left-handed. I am very stupid when it comes to handwriting. But as long as you can see what I wrote, and as long as you understand what I say, I am happy for you. Okay, let's go on. Aha. Here I have the following sum. This sum says fx is this, but it is also this. What did they do? They took this one, they got x plus 2 as a factor, and they divided this one into this one. These two are exactly the same things. They actually, in this sum, made it very easy for you. Because if you want the x-intercepts, you need to make this y 0, and then you need to factorize this whole thing into 3 different factors where possible. So they did it halfway for you already. You use the remainder theorem normally to do that. We'll get to one like that also. Calculate the coordinates of the turning points of the graph of f. Now to find the turning point, it's a maximum and a minimum, right? We are now busy with a 3rd degree graph. And the 3rd degree graph will have 2 points, where one will be maximum and another one will be a minimum. And there can be 3 x-intercepts, but there can also be less. It depends on the given equation. But because of that 3, it says 3 x-intercepts is possible. Okay. Now for the turning point, I'm really going to use that one. I'm not going to use that one because I need the equation in this form. Why? The turning point is the first derivative equal to 0. Maximum, minimum, first derivative equal to 0. And we talk about maximum and minimum because it's a turning point. It reaches a minimum when it's down underneath here, and when it's on top there, oh, my hand is bigger than the paper. Then you have a maximum turning point. Right, people? So I want a turning point. So what am I going to do here? There's my turning point. Let's go there quickly. Turning point, maximum, minimum, and in the corner of my blackboard, this was stood there while we were doing calculus, and that I wrote this like this. And it was there all the time, because when you do applications, this is also applicable. Turning point. The first derivative equal, you see that 0 there. Oh, I love it, I love it. Because the first derivative on its own only gives us a formula for the gradient at any point on that graph. But the moment I make that 0, I will be able to find, firstly, the x values where I will reach a value, a minimum or a maximum, and from there, the y values. In other words, the y values will give me the minimum and the maximum. Let's see. First derivative. There's the first derivative of that original equation. I think you can all do that by now. Put it equal to 0. Factorize. Now, people, if you have a problem factorizing, don't waste time. Jump into the formula and do the formula. This one wasn't so difficult because 3 can only be 3 times 1, and that's 3 also. So you should just decide where to put the 3 and the 3 in the other bracket. Okay. Let's check whether we were right here. The signs must differ. Multiply the 2 here, 1x. Minus 9x, the 2 outside ones, will give me negative 8. So that is how you check whether you did the factorization well enough. And that gave me x equal to negative 1/3 or positive 3. That is only the x values where we will have a turning point. So our turning point at the moment only has x values. But remember, fx is y. So to find the y values, you go back to the original equation. Always, you go back to the original equation. To get your y. There's your original equation. In there, you substitute negative 3 first. Then you take your calculator and you do this, and it will give you 18,51, which I will round to 18,52 when I draw the sketch. I can actually say that there already. 18,52. Okay, now I've substituted that one, then I substitute the 3. And the 3 is going to give me 0. And I saw it when I started this sum. Let me show you. If I factorize that little one, it's going to be x minus 3 times x minus 3. So those two roots will be equal. And the moment you've got 2 equal roots, it means your turning point will be on that root. So it's another little thing that you can remember to correct yourself by, or to check whether you did your sum correctly. That is your turning point now. 3 for x, 0 for y. Negative 1/3 for x, 18,52 for y. So those are your 2 turning points. Next question. Sketch the graph of f, clearly indicating the intercepts with the axis and the turning points. You've only got the turning points. So what do you have to determine now? The x-intercept. How do I find an x-intercept in any graph? y is 0. So there you have y-intercept, x is 0. Oh, I quickly did the y-intercept also. I made x 0, so there's the y-intercept. It is 18. And then I went to the x-intercept. Oh, I said thank you to the person who set this paper because they already did the most difficult job or the difficult job for me. They already got a factor and they already divided it into the original equation. So all I need to do now is to get the other two factors. And there they are now. Okay. That is equal to 0. So my x values will be -2 or +3. Now I'm going to go over to the next page for the sketch because I actually made the sketch, but it was quite a job. And so I made it over again. Now I'm going to draw my sketch. I know now that my x-intercept is -2 and 3. I actually determined it in the previous question. Then the turning point, there it is. I determined it myself in the first question. So now I'm going to draw it. People, if you look at the equation of this graph, let me quickly show you the equation again. There's the equation, that one. Can you see that the a there, this one, in front of the x cube, is positive? This is a positive. So this graph will go up first and then down like that. Please, you must check yourselves by looking at little things. That is very important. So, you know now, I had children that said to me, Miss, I can plot the points and I don't know how to draw the graph. So now, because of the fact that you know that it must go up first, you're going to start here, turn there, through there, y-intercept, x-intercept, and a turning point up there. Two x-intercepts the same, so that is also a turning point. Isn't it beautiful? Yes, people. I hope your graph in the exam will also look like this. I want to give you something else because this is the end of that question. I want to just remind you of something here because I didn't find a question like that in the 4 papers that I used. The turning point of this graph, the turning point, is the x-intercepts of the derivative of this graph. So there's your the x turning point is -1/3. X-intercepts means y is 0. The other turning point was 3 and 0. The x is 3, the y is 0. So, if they ask you to draw the graph of the first derivative of that graph, it will be a parabola. And that parabola will have, there it is, that's the first derivative. That parabola will have x-intercepts, that one and that one. So you've got it already. Okay, can you see it's very true. If you factorize that, you're going to get the x-intercepts. We did it previously for the turning point. Okay, don't get confused with turning point and x-intercept. The turning point, you make the first derivative equal to 0. For the x-intercepts, you make y 0. You use the remainder theorem, if necessary, to find the 3 factors of my 3rd degree graph. Okay. And there it is, and then from that, you can find your axis of symmetry for the parabola, and you can substitute that into your equation, and that will be, and there I drew, this graph is the graph of the derivative of fx. Isn't it lovely? So please, people, don't forget this. Because if you really want to score and they give a question like this, you must be able to do it. That is the graph of the first derivative. Those were the turning points of the fx. This we determined ourselves. We got the derivative, and from that we could get the y-intercept of our parabola. Isn't this beautiful? I wonder who thought about all of these things. But I'm glad he did, because this is so good for us. In any subject, if you can do maths well, you will do better in all your other subjects. Because maths makes you think in a logic way. That is the important thing about maths. I love this. I told you that calculus is my favorite. Right, let's go to the next one. Throwing away all my papers here. There's the next one. Aha. The sketch below shows this graph. Now let's look at the sketch below. There it is. Lovely, lovely, lovely. Again, a third-degree graph. There they gave you the equation of this graph. That's all. Then they said the x-coordinate of A is 1. Oh, isn't this lovely? C is another x-intercept of H. X-intercept, and there's another one. But I don't think we're going to work on that one. Right, let's go on. The first question, determine the derivative of that. Now that is the derivative of that equation. 3x squared, 14x, 14, and the 8 doesn't have a derivative. You just throw it out. Okay, next question there. Determine the x-coordinate of the turning point B. Turning point. First derivative equals to 0. You see my 0 there? You see it? You remember it? Please. Okay. Right, people. Then I take the derivative. There's the derivative. I put it equal to 0. They want the x-coordinate of the turning point of B. They don't even want the whole turning point there. So I take that derivative equal to 0. Factorize. Oh, I saw that it cannot factorize. So what do? Run to the formula. Substitute into the formula A and B and C. There you have it. Take your calculator. Work that out carefully. Look at the signs. Remember, if I square any negative number, it becomes a positive. Okay? Right, then I go on, and I got 196 for that one. I got 168 for that one, and I got a 6 there, and my 14 is still there. From there, I go on, and I get my x values. And you use your calculator there, people. X is equal to 3,22. It's not, it is an irrational number, so I rounded it, or 1,45. What did they want? They wanted the x-coordinate of B. Now, which one do you think will be the x-coordinate of B? The smaller one or the larger one? Now, people, this turning point is much larger than that one on the x-axis. So that will be the x value for, there it is, this is the A turning point. Yeah, man. B, that is B. This is not A. Sorry, this is that one with no name. So the smaller one is the turning point of B. They only wanted that, so you keep to that. Okay, people? Right. Then we go to question 8.3.3. They said, calculate the coordinates of C. That's an x-intercept. Can you see that? So we'll have to find all the x-intercepts in order to find C, because C is the biggest one. It's the furthest from the origin. But people, they gave us something. And just like you must please pay attention for the things that they give you. They said the x-coordinate at A is 1. That's why I say fill it in on your sketch. Normally, if you use the remainder theorem, you must test for a factor. Test x minus 1, because I know now that it is a factor. But if it wasn't there, you would have started by checking what factor will give you a remainder of 0. X minus 1, I took that one, and then I substituted 1, positive 1, into my equation, and what happened there? I got a remainder of 0. So that, but if they don't give you the 1 there, you'll have to show your test. F1, substitute 1 in there, and that will give you 0. Then you say, therefore, x minus 1 is a factor of hx. You have to show it. In this case, we didn't have to show it because they gave us that 1. So the factor there is x minus 1 to give me a positive 1 there. Okay. Right, people. Then we go on. We factorize the next 2 brackets. We got x squared minus. How did we get that? How, people? I don't want to waste time on this. Because some teachers say to you, use long division. You take that factor and you do long division with your original equation. Other people teach you a short method. I've got another short method maybe, because there's 2 different short methods. I will quickly show you what I do, but only once. I'm not going to waste time on this because your teachers should have shown you this. Okay. You look at this, and you say, x goes into x squared, x times. X goes into x cubed, x squared times. I'm dividing that one into that one to get this one. Negative 1 goes into negative 8, positive 8 times. Then, I can either do this or multiply this. I'm going to multiply these 2. Negative x squared. What do I need to have in my sum? A negative 7x squared. So what must I add to negative x squared to get to negative 7x? A negative 6, and you put it in there. Or, you can multiply the 2 on the outside. 8x. But I want a 14x. So I must, from my 8x, it's a positive 8x, I want a positive 14x. Why does this not work? You've got to add 6 there in order to get to 14. Let me quickly look at this one again. I've got a negative x squared, but I need a negative 7, so it becomes negative 6x there. Not square, only an x. Let me quickly see why I can't work with this one in this case. 8x. But there's a negative 6. Oh no, the x6 must be still 15. X times 8 is 8x. If I multiply this x, if I multiply that one by that one, it should give me a positive 6, and that is exactly what it is giving me. So it's quite fine. But your teachers have taught you a method. Please don't now change to another method. Use the method that you're used to. Long division, the one with the K, or this one that I am using here. Okay, people, let's see. Now, I want the factors of that. Oh, wonderful. Very easy factors to find there. Then, I put that equal to 0. This is supposed to be equal to 0. And then, people, my values for x will be 1, 4, and 2. This is a very traditional third degree graph. 3 x-intercepts, 2 turning points. It's going to be a lovely graph. But there it is already, so you don't have to draw it. People, one year they gave the learners an equation, and they said to them, draw the graph, showing all the turning points, all the x-intercepts for 17 marks. Can you really imagine that? It's a bargain if you get a sum like that. They just said, draw that, showing all the points necessary. Okay, from there, the next question there. The coordinates of C. Can you see C will be 4? That one will be 1, which is definitely is. 2, 4. So the coordinates of C will be 4 and 0. Not so difficult, ne? Actually very, very straightforward. Right, people, the next question, the graph of h is concave down for x smaller than k. Calculate the value of k. Now let's have a look. Where is this graph concave down? Go back to the graph. Aha! This graph is concave down over here. Have you got it? And now they say, calculate the value of k. Now where do you find your point of the concave point? You take the first derivative, and then you get the derivative of that derivative, the second derivative, and you put that equal to 0. 6x minus 14, they said, calculate the x is smaller than k. So you're going to say 6x minus 14 smaller than 0. So x is smaller than 14 divided by 6. But x is smaller than k, so k is that value. So if they talk about the concave, you work with the second derivative to find the value of the k in this case. Okay. The stationary points, the second derivative gives me the point where the graph, let me show you, start changing position. Here is concave down, and there it is concave up. Remember that. And for that point there, you use the second derivative. This sum was not so difficult, but people, it's also very important that you do all the simple examples plus the more difficult examples, because you want to get full marks for your simple examples, for the easier ones. And then you want to get a lot of marks with the more difficult ones also, so that you get your high marks that you are aiming for. Next one. Another graph. I tried to do something different in each of these graphs, show you some differences in these questions. Okay, now let's have a look. I just wrote that there because you're going to need this knowledge later on in this graph. The equation of the curve is given, but they left out the b and the c. Oh, people, you must be able to do a question like this also, where b and c are constants. Then they say, the first derivative, 1, substituting 1 into the first derivative will give you 12. If you substitute 1 into the second derivative, you will get 24. And now they say, solve for, show that the equation of the curve is this. So what do they actually want? They want you to find b and c. And this is all you have that you can work with. You've got 2 variables that you must determine. So, simultaneous equation. And how am I going to get to that? I'm going to use that information. I'm going to say, right, the first derivative is equal to 12. The second derivative will be equal to 24. Then I find, that is the equation. I wrote it again there so that we have it in front of us. And then I got the first derivative by using my rules. That is the first derivative of my fx. 9x squared plus 2bx plus c. Okay, now I've got the first derivative. So from there, I am going to say, right, the first derivative is equal to 12. First derivative, that's your first derivative. If I put a 1 into the x, because they said the first derivative, substituting x by 1 will give you 12, not the first derivative itself. So that one gives me, if I put 1 into x, I will get that, and I can say that is equal to 12. This is a sum where you have to think a little bit further. This is most definitely either level 3 or 4. I would actually say level 4. Right. Then you take the second derivative. This one, we simplify that one first, and we make that our equation number 1, because we decided on simultaneous equations. Then I take that one. I take the second derivative, which will be 18x plus 2b. There it is, 9 times 2, 18, 2b, the x is gone. Right, I take that. I put a 1 in there for the x, because that's what they gave us. You must be very careful with the sum. And then x times 1, 2b stays as it is. And then I call the negative 24 to come in there, because they said the first derivative, where x is 1, will be equal to negative 24. Right? And then I take the 18 there, divide by 2, and I will have a second equation. Again, people, they are very kind to us, because this second equation is done already. It is there. You've got a value for b already by looking at that equation. So all you do know now, you take 2 and you put it into 1. If I take 2, where b is negative 21, I put it into number 1. There's my number 1. 3 is equal to 2 times 21, negative 21, plus c. So I can now determine the value of c. And c is going to be negative 42 taken there, positive, plus 3, c is going to be 45. Am I right? Let's go back to the question. Voila! There's the question. They said, prove that the equation will look like this. What did we get for b? Let's see. Our b is negative 21, 100% correct. And our c is 45, also 100% correct. There's your c. And that is the equation, and that's exactly what the equation should look like. This is b, and that is c. But they didn't ask the value of b and c. They asked us to write the equation. Sometimes they will say determine the values of b and c, then you do it like that. Okay. Right, people, the next question, there is question D. Yeah, question C. Why did I do that one? Oh, that was our first question. Now, it's B. Give the values of x for which the graph is concave down. Give the values of x for which the graph is concave down. Now, people, let's go back to our graph. Concave down. What is the values of x where the graph is concave down? You will have to get your second derivative. You can't read it off from your graph. The second derivative gives me the value of x that will give me a concave down graph. So let's go to the second derivative. There it is. There it will be concave down. So I will now substitute the b. Why do I have a b there? That's my derivative, but b is negative 21. So we can substitute the b there by negative 21. Put that smaller than 0. Why? Because the question said, give the values of x for which the graph is concave down. So now that means your second derivative must be smaller than 0. If it's concave up, your second derivative larger than 0. Solve for x there, and you will have x is equal to negative 42 over 18. But the negative is on that side, becomes a positive. So it's actually 18x is 42, so x is 42 divided by 18. You can simplify that by dividing by 6 on both of these fraction sides. Have you got that? Remember now, concave down, second derivative smaller than 0. Concave up, second derivative larger than 0. Solve for x. Wonderful. Another one. Let's see what we have here. Oh, but it's still that question. It's still that question, but I had to go to a next page. So let's go back to the graph also. Put the graph there. If we maybe need those things, we will have the graph in front of us. Okay? Okay. There we have that. And we have the graph there. Okay, now, they said in question C, let's read the question first. The question says, if LM, there's your LM, is a tangent to the curve at 2 and 3, determine the length of MN in terms of P. If N is the point P0, I wrote it there on the graph already. What distance do they want? They want this distance, this one here. It's a y value. Can you see that? Because it corresponds on the y. So that distance will be the same as that distance. So it's a y value for that point of M that we are looking for. Only the y value. Then we will have that length there. Now let's see what we can do about this problem. Okay, I wrote there N is P0, and I also wrote there that L is 2 and 3, and LM is a tangent. Now people, if the x coordinate of N is P, what will the x coordinate of M be? Yes, also P. We don't have the y. We are actually now looking for the y. Because if we have that y value there, we have the distance of Mn. And that was the question. Determine Mn. That was the question. So keep that in mind all the time. So people, now we must make a plan to find the coordinate of y. Now let's see. You remember the gradient of a tangent is the first derivative, but it's in terms of x. But I've got a point where it touches the graph. It says x is 2. So now we take the first derivative. That is the formula for the gradient at any point of x. So now I can say, go back to my point where it touches the graph, x is 2. And I substitute the 2 into that equation. Gradient at x is 2. This is only the formula. Substitute the 2 in there, do the calculation, and voila, that gradient is equal to negative 3. Right, let's see whether we're right. It's 36 minus 84 plus 45. It will give me negative 3. So the gradient of that line is negative 3. Now people, I've got the gradient and I've got a point on the line. Can I determine the equation of that tangent? Because if I got the equation, I will be able to substitute P into this equation to calculate the value of y. And that will be the length of Mn. The final question was determine the length. Can you see this is level 4, ne? You must think in this sum. Right. I actually wrote there the vertical length is always the y value. Now let's see. We're going to find the equation of the tangent. At the moment, we've got the gradient. So the equation of the tangents looks like this at the moment. Analytical geometry, algebra, everything here must be used. Okay. Now let's go on. I want C because I want the equation of the tangent, so that I can go back to M and find the value for y. So I've got a point on that graph. It's 2 and 3. I'm going to substitute that point to calculate the value of C. Substitute the point. This is x and y. Y is 3. X is 2. It's a negative 3 there. So I've got a negative 6. Take it over to the other side, and it will become The C stays, oh, I took the C over there in this case. Sometimes I'll just leave the C there. C is negative. That 6 is negative. The 3 will become negative. So negative C is negative 9. So C is going to be equal to positive 9. That is the equation of the tangent. Right. Now I want the point M. It is on, there's the point M. It's on that line. So if I substitute P into that equation, I will get the value of Y in terms of P. People, if you've got a point on a line and you only have the X value, you take that X, you substitute it into the equation of the line or the curve or whatever, and you will get the value for the Y coordinate. Okay? So what I'm going to do now, I'm going to substitute X by P. I'm going to substitute X by P, because I know now that's I wrote it there again. The X of the N there is P. The X value of the M there is also P. So what I'm going to do now, I'm going to substitute that P into my equation, wherever I've got an X, because it's the X coordinate. So there's my equation. I substitute it in there. Instead of X, I write a P. So 3P plus Q, that is going to be the Y value. So if that is the Y value of that coordinate, then Mn is going to be negative 3P plus 9. They asked this question in terms of P. So there it is. Let's quickly recap. Why can we say that that is the distance Mn? Look at the graph there, people. Mn, that length is actually the Y value there. Because this length and this length will be exactly the same. So if I can get this, I have the length of Mn. And we got the value of Y. We got it. It was actually 3. Where is it now? Negative 3P plus Q. Wonderful. Have you got that one? Okay, people, the next question of this graph. Let's have a look. The next question is, I'm going to keep it there so that we can look at the question. Okay? It is D. Solve for X, giving the exact solution of, and that I wrote there, so we can actually put that paper away. No, we keep it here because we need the derivative and fx again. Right, let's have a look. They said, solve for x giving the exact value of the solution of this one. And there I put a smaller than, because that equal there should not be there. Just make that a smaller than, okay? Right, people? Then I said, this is the derivative of my equation. Let's see if it's true. There's my equation. It is over here. Let me see. This one, I want to show you the equation quickly. Let me put it there. There it is. And the derivative of that is going to be what I wrote there. And this derivative must be smaller than 0. Why did I say that? Because they said the derivative divided by fx must be smaller than 0. Now people, if fx is positive, the derivative can be negative. And that will make me a smaller than there. I will have a smaller than there. So I can only prove the derivative smaller than 0. And that is a quadratic equation, and it is a quadratic inequality. So now I do an inequality exactly as we did it when we did equations. We can simplify that by dividing by 3. Then you've got to factorize there. Your 0 points will be 5 over 3 and 3. Then you draw your little graph there. 5 over 3, 3. This graph is positive, so it is a smiling graph. I want the solution where this graph is smaller than 0. Exactly like the previous one we did when we did equations. The smaller than will be here. The bigger there, because it's all about the y values of the graph. Here the y will be negative, there the y will be positive. So, the solution to this is x is larger than 5 over 3, but smaller than 3. Then this one will be negative. This one is positive, so then both of them divided will give us a negative. We only made that one negative. There. Can you see that? So that one is positive, and there we have the solution for f, the first derivative of f divided by f. Wonderful. Woo! People, I get so excited, and I hope you feel like that by now also. People, maybe it's not a good thing to look at all of this on one day, because it's the whole of paper 1. Choose the topic that you want to look at, and look at the topic, and talk about it afterwards. Choose another topic, look at it, and talk about it afterwards. But don't do all 5 topics in one day. Right, people? That was the end of that question. I wrote that there again, but I actually told you that in a previous sum. The turning point of a cube functions are the x-intercept of the derivative, which will be a parabola. I always want to remind you a lot, because saying a thing once, you don't remember. But if I repeat it a lot of times, you will remember. Now, I can repeat. I've got a lot of patience. I can repeat and repeat in class and repeat again. So if you say, oh, what stupid lady is that, repeating everything again, you'll see it's going to help you to remember very important facts. Right, let's go to our next question. Right, people, I've got another graph for you, because this one is different from all the others, and last year they asked very, very difficult graphs in the calculus. So let's have a look at this one. Sketch a possible graph of y is fx, and then they give you the equation with no numbers in. They say the second derivative is smaller than 0, where x is larger than 0. And the graph has a point of inflection at 0 and 1. Wow. Let's start. It's only 3 marks. Only 3 marks. If it's the point of inflection is smaller than 0, it means concave down. So it's going to be concave down, where x is larger than 0. In other words, people, concave down on the positive side of the x-axis. That A is positive, so the graph is going to go up and then down. And the graph has a point of inflection at 0, 1. Now, people, the graph must go up first, and the point of inflection is smaller than 0. Then it is concave down for x larger than 0. Now, I think I made a terrible mistake here, because x is positive here. Concave down, that's right. But x larger than 0, it means that this graph has the concave down somewhere here. X larger than 0. Let's redraw this graph for you. I'm going to do it freehand. It's got concave down on the positive side of the x-axis. There. Then it's got a point of inflection at, they said, 0, 1. It's here. And then this graph will go like that. Can you see that? It's going to be only on the one side of the x-axis. Because they said concave down, point of inflection there, it's where the shape starts changing, and the concave down is where x is larger than 0. So people, there's the graph that you should have for this one. It's concave down, point of inflection there, and x is larger than 0. There's your rough graph for 3 marks. But you know, people, you waste quite a lot of time on such a question. So please, if you're not sure, leave it, come back later to this graph. Okay, that is a simple question for 3 marks, but definitely a level 4 question, because we have to think how this graph is going to look. Thank you, people, for that one. Now, let's go to the next one. We've done graphs, a lot of them, for calculus. Now, I'm going to do applications with you. The first application that I want to do example 8 with you. Example 8. Now, let's have a look. Applications in calculus means you are going to work with areas, volume, surface area, distance, speed, time. But in all of this, I want you to remember one thing. We are going to work with the derivative all the time. To find a maximum area, first derivative of the area formula equal to 0. To find a maximum volume, first derivative of the volume formula equal to 0. To find a rate of change or the velocity, first derivative. The maximum velocity, first derivative equal to 0. If it's maximum or minimum, you put the first derivative equal to 0. Now this is our first application, and it's all about height and time and a ball that's been dropped. A ball is thrown into the air and its height h above the ground. After t seconds, h is going to be 5t squared plus 25t plus 4. T is your time, h is the height of the ball. And the height can be determined by substituting time in there. They gave the height in terms of the time. So the first question, the height of this ball above the ground after 2 seconds. Oh, people, they didn't say anything about velocity or rate of change. They said, determine the height of the ball after 2 seconds. And there's the height in terms of the time. So what we're going to do here, we're going to just say height is, that's your height formula given to you. Then you're going to say height after 2 seconds will be 2 squared plus 25 times 2 plus 4, and that is going to give you 34 meters. So you're going to throw the ball up, and after 2 seconds, it will already reach a height of 34 meters. Can you see what we're doing? We are merely substituting. The thing is, you must read your question very well. They want the height, and there you have the height formula. So all you do now, you substitute 2 in there. If they ask the height after 5 seconds, you put 5 into that formula to find the height. Substitution. This whole thing is substitution and derivative when necessary. Let's go on to the second question. The velocity of the ball at that moment. The velocity of the ball at that moment. Velocity, first derivative. So let's get the first derivative. And at that moment means at 0. So You get the derivative, there it is. Put it equal to 0 and find the time when the velocity will be of the ball at that moment. That is the time. So now you want the maximum height. Think carefully now. They said the velocity of the ball at that moment. Now the velocity at that moment means time is 0, or not, the height is 0. The height is 0, and that is the derivative. To find the velocity at that moment, no, I'm sorry, this is the first derivative equal to 0. Let's go back to the question. The velocity of the ball at that moment. That is the first derivative equal to 0. Solve for t. At 2.5 seconds, the velocity of the ball will reach its maximum height. Question is very vague, but remember this. The velocity of the ball at that moment is the first derivative. But to find the height at that moment, you will have to make the first derivative equal to 0. Let's go to question C of example 8. The maximum height of the ball above the ground. Question C. The maximum height of the ball above the ground. That is C. Now to find the maximum height, people, you've got to do it with the first derivative. So you're going to take the first derivative, put it equal to 0, and you'll get the time when a maximum height has been reached. Then you take that time, you substitute it into your original equation, which you have there for height, and you will get the maximum height after 2.5 seconds. That's the maximum height. Can you see after 2 seconds, the height was 34. So after 2.5 seconds, the height was 35, and that's the maximum. That is where the ball started turning back downwards to the ground. So for maximum height, please people, you're going to take the first derivative equal to 0. And look what you're working with here. You're working with h and t. So you cannot use x and y in these sums. Did I do B? The velocity of the ball at that moment. Oh, it's at the moment where h is 2. I didn't do that one. I started with C immediately. Let's have a look at B. The velocity of the ball at that moment. That's why I was confused here. Okay, B. Let's see. The moment was 2 seconds. Now they want the velocity after 2 seconds. Velocity means first derivative. Maximum velocity, first derivative equal to 0. It's exactly like the gradient of the tangent is the first derivative of your graph. Exactly the same. The velocity at that moment is the first derivative. That's the formula for the velocity. It's a first derivative. So now you put a 2 in there because that's the time that we got there for A. And we put the 2 in there and that will give you 5. So the velocity will be 5 after 2 seconds. Right. Let's go to D now because we have done number C already. Number D. The question there is, the time taken to reach a downwards velocity of 5 meters per second. Okay, now they're giving you the height, the downwards velocity of 5 meters per second. No, they're giving you the velocity. So, you go to your first derivative, because that is the formula for the velocity. I want you to remember that. It's the formula for the velocity. Now, if they say a downwards velocity of 5 meters, the ball is coming down now, and if it's coming down, it will be negative for the velocity. So instead of the velocity, you put in a negative 5. That's your derivative, but the 5 must be there. This is the time. That's why you substituted it into the t. But now this is the velocity, and that is the formula for the velocity. So we're going to have 10t is 25 plus 5, which is 30. So t is 3 seconds. What was the question? The time taken to reach a downwards velocity of 5 meters. So the velocity is 5 meters per second, and it took 3 seconds to get there. Have you got that? People, it's substitution and first derivative. That's all you need to know about this. Because you know what? In science, you do these things way different from what we do here. So please, if I ask you a sum with time and height and velocity, rate of change, remember velocity and rate of change is the first derivative. It's a formula for the first derivative. From there, it's substitution altogether. Try to remember it like that. Thank you. Another one. Okay. This is actually sums that you might have done already, but I am doing it again because they are all very good examples. They say a solid cylinder is cast from 10 liters of molten metal. This cylinder is then covered by a layer of rust-proof paint. So in other words, it's all about the area, the surface area around this cylinder. Calculate the radius and the height of the cylinder in centimeters such that the minimum quantity of paint is to be used. Wow! What do they actually want? The radius and the height of the cylinder in centimeters such that a minimum quantity of paint is to be used. If you see the word minimum, what are you going to use? You're going to use the first derivative, equals to 0. Now let's have a look at this sum. It's all about surface area and volume because they gave us a volume also. Can you see that? So we are going to use the volume, and then from there we're going to go to the surface area because we've got to find H and R. So let's have a look. We're going to use two things. The volume is 10 liters. But if we take 10 liters to centimeter cube, it's going to be 10,000. You times it by 1,000. So this is centimeter cube, and this is your formula for the volume. The formula for the volume is always the area of the base, and this base is a circle. So it's pi radius squared times the height. That will give you the volume. I want the height and the radius. So from the volume, I'm going to write the height in terms of r and pi. So I'm going to keep the height on this side, and I'll divide my 10,000 centimeter cube by pi r squared. Now I've got the height in terms of pi and r squared. Right, people? Now, let's go further. From here, we can now say that 4 pi r, that's your derivative of this one, minus 20,000 over r squared, the derivative of that one, will be equal to 0. Why? Why will that be equal to 0? Let's have a look again, people. If I take 4, the derivative of that, no. It's equal to 0 in order to find the maximum or the minimum paint that we must use for painting this cylinder. That's why we made the first derivative 0. For minimum in this case, ne? Okay, now we're going to say surface area. we only used the volume to get to H, but H is still in terms of R. So now we're going to go to the surface area. Why? Because this cylinder must be painted, and you only paint the outside of such a cylinder. So they didn't say they are going to paint this on the inside also. Covered by a layer of rust-proof paint. Now, how do I get the surface area of a cylinder? Ooh, and that is a problem. Let's have a look. A cylinder has a circle on top and a circle at the bottom. The area of a circle is pi radius square. So, there's two of them, because they didn't say the cylinder is open. If it's open, there's only one of them. So there's two round parts in this cylinder. Then, if you cut this cylinder open, so you cut there, this cylinder will look like this. You did this in your lower grades also. It will look like this. It's like a label around a tin. If you take that label off, it's going to be a rectangle. So this part is actually a rectangle that has been folded around the circles. So to find the surface area, we've got to find the area of those two circles. There it is. And then we've got to find the area of this label, or the round part of the circle. Now, this fits around the circle. So if we can get the perimeter of the circle, or the circumference, that will be this length of our rectangle. Because we need the area of this rectangle. Now people, if you cut it there, what will the breadth be of this rectangle? It will be the height. Can you see that? There's a height. You cut it open, it folds open. The perimeter will be that part, or the circumference of the circle. And that will be the length. And the breadth of this rectangle will be the height of this cylinder. So, for the surface area, we've got those two circles, and we've got this one, the rectangle. It's length times breadth. But what is the circumference of a circle? What is the circumference of a circle? The length is 2 pi radius. Can you remember it? You should have done this in grade 11 also, the measurement. But now you are using it in calculus application. It's not easy. It's really not easy. Right. Now that is 2 pi radius, and that is height. So for the area of this rectangle, you say length times breadth. 2 pi radius times height. There you have it. This we call the surface area. Surface area is all the parts that you can touch on the outside. Sometimes you've got to paint inside also, then you double that surface area for the inside. Okay, but this cylinder is closed, so they can't paint it on the inside. Okay, so that is my area. There it is. Now, I've got H in terms of R. So what I do now, I substitute the H here into the H here. This now goes into this H. Can you see it there? And now I've got only R. I don't know what it is. So I can solve the R now in some way. Let's have a look. The area now, I simplified this. It's going to be 2 pi R squared plus. I can multiply these two, this with this, because it's right next to the bracket. I remove the bracket. So I'm going to have 2,000, and the pi R is going to be cancelled there. So I'm going to have 20,000. There's 1 R left there over R. Now I'm thus far. I need the value of H and R. I don't have any values yet. It's all in terms of the other. So there I've got an equation where I have only R's in it. Then I say, right, The area is, you take the r to the top, because I want to differentiate this one. My English is suddenly not there. Okay, I want to get the derivative of that one. So I'm going to take the r on top, because we cannot derive unless we have the r on top. It cannot be in the denominator. Right, now I've got the area written like that in terms of r. The h is out. Then I say, right, first derivative. 4 pi r squared. That is the one, and the derivative from that is 4 pi r. The derivative from this one is negative 20,000 now, negative 2 there. Now I've got the derivative. I take the derivative, I put it equal to 0. And voila, people, what can we do now? We can solve the r. We've got an equation, and we've got a 0 there, not an AR like there. So we're going to solve the r now. Now let's have a look. 4 pi r cubed minus 20,000. Where on earth did I get that 4r cubed? I took that one as my common denominator, that one on 1. 1 goes into r squared times that one. It gives me 4 pi radius cubed minus 20,000. I just actually simplified that, those two expressions there. Right, now I've got 4 pi radius squared is equal, or minus 20,000 is equal to 0. Take the 20,000 to this side, and that gives me 4 pi radius cubed. Then I divide by 4 on both sides, I get 1,000 there. And then on this side, I've got pi r. I divide by pi also on this side. Because why? I want to determine the value of r. You see what we did all the way? At first we used the knowledge about the volume to find h in terms of r. So then I took that h in terms of r and I put it into the surface area formula so that I can get rid of the h. And because of that, I can now take the derivative equal to 0 because I want the minimum height needed, and I can solve my r. There's only an r there. I already substituted the h there. And now I've got 5,000 over pi is r cubed. I divide it by 4 pi, 4 pi. Okay, and this gives me r is the square root, the cube root of what we have here. And the cube root of what we have here is 11,67544. And I'm going to round it to 11,68. That's the radius. Now we still need the height. We only have the height in terms of the radius. So now we take that radius, we put it into that formula. Pi radius squared. And I'm calculating that with my calculator, and this is what the height is. So my r is this one, and my height. People, this is not for sissies, let me tell you that. But if you can do one on your own, you will be fine. Because it's always, mostly, you've got two situations. You use the one, in this case it was the volume. They didn't give that 10 liters for nothing. You take the volume and you can write the one in terms of the other, h in terms of r. Then you do the surface area, because that's where you have to come to. And you say, right, there's an h in the surface area. I substituted by that h there. Then I've only got r's. Then I say, right, for a minimum, the first derivative equal to 0. Put the first derivative equal to 0, solve for r, and then go back to that h. It's actually like going back to equation number 1. But these equations were not given to you. You had to find them yourselves. And then you've got your height. You use the volume to find the height in terms of Then you use the surface area where you actually want to come to, and you substitute the h in that formula. Only r's, first derivative equal to 0, solve the r, substitute the r into h, and there you have your value for r as well as h. Wow, people, not so easy. Let's have a look at another one. I want to do this one because this one was a very regular question when we had higher grade and standard grade. So let's see whether you are going to cope with this one. It's much easier than the previous one. A rectangle PQRS is drawn with P and Q on the x-axis and R and S on the parabola. There it is. P and Q on the x-axis, R and S on the parabola. Then they said, if Q is the point x0, determine the coordinates of P and R. Voila. Let's see. This is a parabola around the y. So this x is going to have the same value on that side, but it will only be negative. If this was plus 2, this would have been negative 2. So the coordinates of P will now be negative x and 0. To find RQ, can you see it is a y value there? The y value of R, of the coordinates of R, that will give me the length of RQ. Because all these sides, it's a rectangle, will be exactly equal. Now, we've got the x coordinate there, it's x. We need the y coordinate. So what we do now, we go to the graph. That is the equation of the graph. We know that the x value of the coordinates are x. Substitute x in there. What will y be? Exactly what it is there. So the y value here will be 2x squared minus plus 24. Have you got that? Right, people. So RQ is exactly the equation of the graph. Excuse me. I'm so in a hurry to get to the answers. Solutions. Let's say you get this one by symmetry, because this is a line of symmetry. So this one will be negative x and 0. P is the reflection of Q about the y-axis. So positive x becomes a negative x. Very easy. The coordinates of point R, x, and if you put x in there, it stays exactly as it is, and that is your y value. And the y value there will be the length of RQ. There it is. So RQ is going to be that length, that one. But we haven't asked the length yet. Now they said, B, determine PQ and QR in terms of x. Right, lovely. P to Q, what is the distance? It's x minus x. It's positive x. Because 2x. It's x plus x. Negative x is only the point there. But the distance there is x. And the distance here is also x. So what is your length? 2x. There it is. Now let's have a look at RQ. We actually already said. The RQ will be the coordinate of the y there. And that is negative 2x squared plus 24. If you have an x there, the y will be exactly that. That's the most important part that you must understand, people. Then we have the length and the breadth. There's the QR, length and breadth of the rectangle. Then the next question, the area of PQRS in terms of x. Very easy, because area is length times breadth. And that is the length, and that is the breadth. Times them, remove the brackets, and you will get area equal to negative 4x squared and positive 48x. There you have a formula for that area. Next question. the area of the largest triangle that can be drawn. Largest? Maximum. The maximum area of that rectangle that can be drawn. So, take your area formula, find the derivative. Take that derivative, put it equal to 0 for a largest, maximum. Large and maximum is the same meaning here. Okay, then solve for x. And you will take the 12 there, the 48 there, and in the end x squared is 4, so x is going to be 2. A distance can never be a negative, so it's only 2x larger than 0. It should be because everything is going about distance here. Okay, people, so x is 2. Now I've got x, but I want the largest area that can be drawn here. The area of the largest rectangle that can be drawn. That x, it's when x is 2. Then you will have the area of the largest rectangle within this graph. Like turning point. First derivative equal to 0. You find an x. The x is the x value of the turning point. You take that x, you substitute into the original equation to find the y value, which will be the maximum or the minimum or the largest. So I've got x now, first derivative I used there. Then I go back to the area formula, which is that one, and I substitute x into that one. And if I substitute x in there, I'm going to get 64 units square. So that is the largest rectangle that can be drawn in this or underneath this parabola. Wow, people, you've got a lot of things to think about after this. You'll have to look at it and make it your own. I'm very glad I could do this with you. I'm not going to do the probability. Another lady will do the probability, and together with that she will do the regression line for data. But I will do the second paper with you also. We're going to do it tomorrow, and the only thing that I'm not going to do is probability. She will do that with you. Thank you, people. It was a wonderful day, and I enjoyed every minute of it because I love what I do. And you know what, people? If you have a dream, live that dream. Because in the end, it's important that you love what you do. Thank you.